Jai Hind to all. Today we start a new chapter, three-dimensional geometry. This chapter is a continuation of our first year chapter 3D geometry also, where we discuss how to express a point in a three-dimensional space, then distance between 2 points, section formula, and centroid of a triangle in three-dimensional space. In this section, we discuss three parts. Our first is direction ratios and direction cosines. Second is straight line in space, and the third is plane in space. This chapter contains 1 mark question, 2 mark question, 3 mark and 5 mark also. So it's a very important chapter. Also it's a very interesting chapter. So try to practice every problems in NCERT. Also do some extra questions in using any other test. Okay. Now we start the class. Now we start our last section of three-dimensional geometry, plane. What is plane? A plane is a flat surface in the sense that a line joining any 2 points lies completely on it. The normal to the plane and its distance from the origin is already given. Then how to form the equation? If a line passing through a fixed point and a perpendicular given vector is given, then how to form the equation? And a plane passing through 3 fixed points, then how to form the equation? These are the main equations regarding the topic plane in this section. First of all, discuss about what is equation of a plane in normal form. Actually, the proof is not compulsory. So, but in this section, I will explain how to get the equation of the plane also. Proof നിങ്ങൾക്ക് ഇമ്പോർട്ടൻസ് കൊടുക്കേണ്ട ആവശ്യമില്ല. ഇക്വേഷൻ ബേസ് ചെയ്ത് പ്രോബ്ലംസിനാണ് ഈ ഒരു സെക്ഷനിൽ ഇമ്പോർട്ടൻസ് കൊടുക്കേണ്ടത്. പക്ഷേ ഈ ഒരു ഇക്വേഷൻ മാത്രമേ നമുക്ക് അതിൻ്റെ പ്രൂഫ് ഡിസ്കസ് ചെയ്യാം. ക്വസ്റ്റ്യൻ: ഇക്വേഷൻ ഓഫ് എ പ്ലെയിൻ normal to a unit vector and the distance from the origin is already given. Equation of a plane normal to a given vector and distance from the origin is already given. Suppose the three-dimensional space we consider a plane. We consider a plane surface. Distance from origin to that plane is already given. Also, unit vector perpendicular to this plane is given. These are the two given quantities. These are the two measurements. First is origin to the plane. Distance from the origin to the plane is already given. And the unit normal perpendicular to the given plane is already given. Okay. So, very plane perpendicular to the unit normal, that means perpendicular unit vector is already given. Also, origin and plane distance. Then how to form the equation? That is, d is a distance. Distance we vector convert unit normal is already given. That is n cap is already given. N cap into d is the vector of origin to this plane. Consider this point is n. So, suppose a plane is perpendicular vector is already given, which is converted into unit vector. You already know when a perpendicular vector is given, is how to form the unit vector. A vector and a modulus value divide. You get a unit vector. Otherwise, unit vector is already directly given. At that time, n cap into d is a vector of O to n. P is any point. You know, P is general point. Joint NP. You know, position vector of P is generally we taken as vector R. Clearly here ON is perpendicular to NP. That means NB dot ON is equal to 0. What is NB? Position vector of P minus position vector of N dot ON is equal to 0. Position vector of P is R minus position vector of N is n cap into d. Because it is a origin to plane distance, I am vector convert here. ഈ പെർപ്പൻഡിക്കുലർ യൂണിറ്റ് വെക്ടറോട്ട് ഇൻഡ് ചെയ്താൽ യു ഗെറ്റ് എ വെക്ടർ ക്വാണ്ടിറ്റി ഓഫ് ON. Dot ON is again n cap into D is equal to 0. That is R dot n cap into D minus യൂണിറ്റ് വെക്ടറുകളുടെ സ്ക്വയർ മീൻ മോഡലസ് എടുത്ത് സ്ക്വയർ ചെയ്യാൻ പറ്റും. യൂണിറ്റ് വെക്ടറിൻ്റെ മോഡലസ് വാല്യൂ ഇസ് 1, 1 square 1, D into D, D square is equal to 0. That is R dot n cap into D is equal to D square, and therefore R dot n cap is equal to, we get answer D, which is the vector equation of a plane normal form. R dot n cap is equal to D. R dot n cap is equal to D. Here equation of the plane formed using equation of the plane normal to a unit vector and distance from the origin to the plane is given. Equation of plane normal to the unit vector and distance from the origin to the plane is already given. Plane perpendicular ആയിട്ടുള്ള ഒരു നോർമൽ വെക്ടറും യൂണിറ്റ് വെക്ടറും പെർപെൻഡിക്കുലർ ആയിട്ടുള്ള യൂണിറ്റ് വെക്ടറും നോർമൽ ആയിട്ടുള്ള യൂണിറ്റ് വെക്ടറും ആൻഡ് ഡിസ്റ്റൻസ് ഫ്രം ദ ഒറിജിൻ ഈസ് to the plane is given, then the normal form in the vector equation is R dot n cap is equal to D. It's a vector form. The proof is not important ആയിട്ടുള്ള അല്ല, by heart ചെയ്താൽ മതി formula. Now this is general form or Cartesian form. You know R is general point. Its coordinate is xi plus yj plus zk. Unit vector, normal ആയിട്ടുള്ള യൂണിറ്റ് വെക്ടർ, ഐ മീൻ പെർപെൻഡിക്കുലർ ആയിട്ടുള്ള യൂണിറ്റ് വെക്ടർ is represented by the symbol Li plus Mj plus Nk, because you know Lm and R, the direction cosines. So its modulus value become 1 because root of L square plus M square plus N square, you know, direction cosine square root of sum. The first video we discussed about sum of the squares of direction cosines is always 1. So unit vector modulus value is always 1 eigenum. So here we denote the unit vector is unit normal is represented as Li plus Mj plus Nk, and D is a constant value. Now substitute this equation to the values to the given vector form, that is xi plus yj plus zk dot Li plus Mj plus Nk is equal to D. In taking dot product we get answer Lx plus My plus Nz is equal to D, which is the Cartesian equation of the normal equation of a plane. This is the Cartesian form of equation, normal form of the plane. Okay. Mainly we concentrate on the scalar vector form R dot n cap is equal to D. That is necessary for finding the equation. Okay. The Cartesian form is Lx plus My plus Nz is equal to D. Our first question. Now discuss some problem based on this formula. Our first question is, find the equation of the plane, find the vector equation of the plane which is at a distance of 7 units from the origin and normal to the vector is 3i plus 5j minus 6k. Find the vector equation of a plane which is at a distance 7 units from the origin and normal to the vector is 3i plus 5j minus 6k. Here given D is already given, D is equal to 7 units. Origin in the plane distance is already given 7 units and is normal to the vector, that is normal vector is given, that is normal vector means perpendicular vector. Plane containing a perpendicular vector is already given. Plane perpendicular vector is 3i plus 5j minus 6k. Okay, D is already given. So here we apply only formula is R dot n cap is equal to D. Okay, we form the Cartesian form, vector form. First of all, we form the normal vector to unit vector. That is, you know formula 3i plus 5j minus 6k divided by square root of 9 plus 25 plus 36 is equal to 3i plus 5j minus 6k divided by root of 70. Okay, now the equation of the plane, you know the normal form is R dot n cap is equal to D. Here R dot, what is n cap? Is we get answer 3i plus 5j minus 6 into k divided by root 70 is equal to, here what is D is 7, and therefore R dot 3i plus 5j minus 6k is equal to 7 root 70. which is the final answer, which is the equation of the plane. The vector form, our question is find the vector equation of the plane which is at a distance of 7 units from the origin and normal to the vector is 3i plus 5j minus 6 into k. Okay. Now we'll discuss one more question based on this topic. Find the equation, vector equation of the plane which is at a distance of, find the vector equation of the plane which is at a distance of 3 units from the origin, which is at a distance of 3 units from the origin and is normal to a vector. And the vector equation of a plane which is at a distance of 3 units from the origin. Here given d is equal to 3 units and is normal to a vector n. Vector n. Normal vector is represented just vector n is I plus j plus k. We form the vector equation. Okay. Here you know the equation, first r dot equation is r dot n cap is equal to d because d is already given. So we use the formula, normal form formula r dot n cap is equal to d. D for d തന്നു കഴിഞ്ഞാൽ നിങ്ങൾക്ക് compulsory use ചെയ്യേണ്ട formula r dot n cap is equal to d. So first of all we form given normal vector to unit vector, that is n cap is equal to I plus j plus k divided by root 3. And therefore the equation of the plane is r dot n cap is equal to d. It is vector r dot I plus j plus k divided by root 3 is equal to 3. R dot I plus j plus k is equal to, we get answer 3 root 3. 3 root 3. That's all. It's a very simple question. Next question is, if x plus y plus z, if x plus y plus z is equal to 1, if x plus y plus z equal to 1, determine the direction cosines of the normal to the plane and the distance from the origin. Determine the direction cosines. Determine the direction cosines of the normal to the plane. Cosines of normal to the plane. That means normal means perpendicular to the plane and distance from the origin to the plane and the distance from origin to the plane. From origin to the plane. Okay. Our question here, equation of a plane is already given. X plus y plus z equal to 1. That means is Cartesian form. That means general form is already given. X plus y plus z equal to 1. We find direction cosines of the normal to the plane and distance from the origin to the plane. That is given, plane is x plus y plus z is equal to 1. Actually the last question is a vector form. The Cartesian form is, you know, in this case Cartesian form, here you know r is xi plus yj plus zk dot I plus j plus k is equal to 3 root 3. When you take dot product, we get answer x plus y plus z is equal to 3 root 3, which is the Cartesian form. So plane in the equation, the Cartesian form last we get answer in terms of x, y, z and constant. This format like plane in the equation last form. So here the plane in the equation the Cartesian form, I mean generalized form already തന്നിട്ടുണ്ട്. ഈ general form ഇന്ന് നിങ്ങൾക്ക് ഇയാളുടെ direction cosines of normal to the plane and distance from the origin to the plane കണ്ടുപിടിക്കുക. That means ഇയാളെ lx plus my plus nz equal to d form കൺവേർട്ട് ചെയ്യുക. കാരണം നോർമൽ ഫോമിലോട്ട് കൺവേർട്ട് ചെയ്യുക. ജനറൽ ഫോമാണ്. ഇയാളെ കൺവേർട്ട് ചെയ്യേണ്ടത് lx plus my plus nz is equal to d എന്ന ഫോം ഇതിനെ കൺവേർട്ട് ചെയ്യുക. നിങ്ങൾക്ക് കിട്ടിയിരിക്കുന്ന ഫോം എന്ന് പറഞ്ഞാൽ എ എക്സ് പ്ലസ് ബി വൈ പ്ലസ് സി ഇസഡ് ഇസ് ഈക്വൽ ടു ഡി എന്ന ഫോമാറ്റിലാണ് നിൽക്കുന്നത്. ഇറ്റ്സ് ജനറൽ ഫോമാണ്. ഏതൊരു പ്ലെയിനിൻ്റെ ഇക്വേഷൻ്റെയും ഫൈനൽ ഫോം ഈ ഒരു ഫോമാറ്റിലായിരിക്കും. എക്സ് വൈ ഇസഡ് ആൻഡ് കോൺസ്റ്റൻ്റ് ടൈം. ഹിയർ ദിസ് ഫോമിനെ നമുക്ക് നോർമൽ ഫോമിലോട്ട് കൺവേർട്ട് ചെയ്താൽ വി ഗെറ്റ് എൽ എം എൻ. ഓക്കെ. First of all here we dividing on the left and right side by coefficient of x y z, that is sum of the squares of x y z, that is എക്സ് വൈ സെറ്റിൻ്റെ കൊയിഫിഷ്യൻറ്റുകളുടെ സ്ക്വയറുകൾ സം സെലക്ട് ചെയ്യുക. ദാറ്റ് ഇസ് 1 square plus 1 square plus 1 square is equal to √3. Okay, first of all dividing left and right by √3. Therefore we get answer x plus y plus z divided by √3 is equal to 1 by √3. ഒരേ ക്വാണ്ടിറ്റി കൊണ്ട് ലെഫ്റ്റ് ആൻഡ് റൈറ്റ് മൾട്ടിപ്ലൈ ചെയ്യുന്ന ഒരു വാല്യൂ ചേഞ്ച് ഉണ്ടാവില്ല. ദാറ്റ് ഇസ് √3 കൊണ്ട് ലെഫ്റ്റ് ആൻഡ് റൈറ്റ് മൾട്ടിപ്ലൈ ചെയ്തു. Now we split, we get answer x by √3 plus y by √3 plus z by √3 is equal to 1 divided by √3. Okay, clearly which is of the form Lx plus my plus nz. You know, L square plus m square plus n square, we get answer 1 because 1 by √3 square plus 1 by √3 square plus 1 by √3 square, we get answer 1. And which is the distance from origin to the plane. Okay, therefore here cos alpha L is equal to answer is 1 by √3, cos beta m is equal to answer is 1 by √3, and n is equal to also 1 by √3, comma d, I mean distance from origin to the plane, answer is 1 by √3, which is the normal form of the equation of the plane. That's a very simple question. Okay, this general form, so I mean Cartesian form, common form. Our plane in the general equation is ax plus by plus cz plus d, sorry, cz equal to d form. This form നമുക്ക് normal form convert ചെയ്യാൻ dividing throughout by mean left and right by root of x, y, z coefficient square root sum. Okay. Now discuss one more question similar to this type problem. In 2x plus 3y plus 4z, in 2x plus 3y plus 4z minus 12 equal to 0. Determine the direction cosines of the normal to the plane and the distance from the origin to the plane. Determine the direction cosines of the normal to the plane and the distance from the origin to the plane. That is similar to the last problem. Okay, first of all we set 2x plus 3y plus 4z is equal to 12. We get a negative quantity multiplying left and right by negative കൊണ്ട് multiply ആണ്. കാരണം distance ആണ് ഈ negative quantity represent ചെയ്യുന്നത്. This is always positive ആണ്. This is already positive ആണ്. Now dividing left and right by 2 square, 4, 9, 16 equal to root of 29. Therefore 2x plus 3y plus 4z divided by root 29 is equal to 12 divided by root 29. Now split here we get answer 2x by root 29 plus 3y divided by root 29 plus 4z divided by root 29 is equal to 12 divided by root 29, which is the normal form. Here L corresponding to 2 divided by root 29, M corresponding to 3 divided by root 29, and n corresponding to 4 divided by root 29, and also distance from origin to the plane is 12 divided by root 29. That's all. Okay, it's a normal form. A general form, normal form, first two questions are converted into normal form, and the last two questions are the final answer. I mean plane equation തിരിച്ച് നമ്മൾ അതിലോട്ട് കൊണ്ടുപോകുന്നു. Normal form convert ചെയ്ത് direction cosine L, M, N and distance from origin to the plane കണ്ടെത്തുന്നു. Okay. Our next section is equation of a plane passing through a fixed point and perpendicular to a given vector. Our next equation is equation of plane passing through a given fixed point and perpendicular to a given vector. Our next top equation is equation of plane passing through a fixed point and perpendicular to a given vector. In our first section, I mean straight line, I already discussed equation of a line passing through a fixed point and parallel to a given vector. This equation of vector r is equal to a plus lambda into m. In that case, Cartesian form x minus x1 by a equal to y minus y1 by b equal to z minus 1 by c. Here the equation is vector form is r minus a dot n is equal to 0, and its Cartesian form is x minus x1 into a plus y minus y1 into b plus z minus 1 into c. Okay, it's very important. Main-ആയിട്ട് നിങ്ങൾ കാർട്ടീഷ്യൻ ഫോം ബൈ ഹാർട്ട് ആക്കിയിരുന്നാലും എസ്റ്റൊക്കെ ഫോം ഇട്ട് ഇതിൻ്റെ പ്രൂഫ് ഞാൻ ഒഴിവാക്കുന്നു. വെക്ടർ ഫോമിൽ ഓർമ്മിച്ച് ചെയ്യുക. മെയിൻലി നമ്മൾ പ്രോബ്ലം അപ്ലൈ ചെയ്യുമ്പോൾ ഫൈൻഡ് ദ ഇക്വേഷൻ ആണ് ക്വസ്റ്റൻ എങ്കിൽ വി അപ്ലൈ ദിസ് ഫോർമുല. Suppose you they want vector form ആണ് നമ്മൾ ചോദിക്കുന്നതെങ്കിൽ we apply formula r minus a dot n is equal to 0. Okay. Here the plane passing point is position vector is vector a and perpendicular vector is vector n. Here Cartesian form x1 y1 z1 represent passing point position pass ചെയ്യുന്ന പോയിന്റിൻ്റെ കോർഡിനേറ്റ് എ ബി സി അത് ഡയറക്ഷൻ റേഷ്യോസ് പെർപെൻഡിക്കുലർ ടു ദ ഇവൻ നമ്മൾ സ്ട്രെയിറ്റ് ലൈൻ ഡിസ്കസ് ചെയ്യുമ്പോൾ പറഞ്ഞു പാരലായിട്ടൊരു വെക്ടറോ പെർപെൻഡിക്കുലറായിട്ടൊരു വെക്ടർ തന്നു കഴിഞ്ഞാൽ ആ വെക്ടേഴ്സ് നമ്മൾ ഡയറക്ഷൻ റേഷ്യോസ് കൊണ്ട് റെപ്രസെൻറ്റ് ചെയ്യും. Okay, here the perpendicular vector is given and that case straight line le parallel vector is already given. In two cases gallum parallel to perpendicular to vector is thannu kayinjal direction ratio ABC കൊണ്ട് represent ചെയ്യും. ജനറൽ ആയിട്ടുള്ള പോയിന്റുകൾ XYZ കൊണ്ട് represent ചെയ്യും. XZ point x1 y1 z x2 y2 z അങ്ങനെ represent ചെയ്യും. ആൻഡ് നോർമൽ ആയിട്ടൊരു വെക്ടർ പെർപെൻഡിക്കുലർ ആയിട്ടൊരു വെക്ടർ തന്നു കഴിഞ്ഞാൽ യൂണിറ്റ് വെക്ടർ തന്നു കഴിഞ്ഞാൽ അതിനെ LMN കൊണ്ട് represent ചെയ്യും. എല്ലാം ഒരു സിമ്പിൾ റെപ്രസെൻറ്റേഷൻസ് ആണ്, ജനറൽ ആയിട്ടുള്ള റെപ്രസെൻറ്റേഷൻസ് ആണ്. അപ്പോൾ ഇക്വേഷൻ ഓഫ് എ പ്ലെയിൻ പാസ് ത്രൂ എ ഫിക്സഡ് പോയിന്റ് ആൻഡ് പെർപെൻഡിക്കുലർ ഗിവൻ വെക്ടർ കാർട്ടീഷ്യൻ ഫോം ഈസ് x minus x1 into a plus y minus y into b plus z minus z into c. Now discuss some one or two question based on this topic. Find the equation of a plane passing through the point is 1, 4, 6. Find the equation of a plane passing through the point is 1, 4, 6. That is x1, y1, z1 is already given 1, 4, 6. And normal to the vector is, that is vector n is already given I minus 2j plus k. And normal to the vector is I minus 2j plus k. Equation of plane passing through the point is 1, 4, 6 and normal to the vector is I minus 2j plus k. Equation, just we on the equation, that means we find the Cartesian form. You know the equation of the plane. Is x minus x1 into a plus y minus y1 into b plus z minus z1 into c is equal to 0. Here x1 y1 z1 is equal to 1, 4, 6 and normal vector is represented by the symbol is ABC. Here ABC direction ratio ABC is equal to 1 minus 2, 1. Now substitute the values to the equation number 1, we get answer. It is x minus x1 correspond to 1 into a is 1 plus y minus y1 corresponding to 4 into b. What is b? B is minus 2 plus z minus z1 corresponding to 6 into c is again 1 is equal to 0. That is x minus 1 minus 2y minus 4 into minus 2 is plus 8. Then plus z minus 6 equal to 0. That is x minus 2y plus z. 8 minus 6 is 2 minus 1 is plus 1 is equal to 0. That's the equation of the plane. Okay, this is the Cartesian equation of the plane. General form of equation of the plane is always in the form ax plus by plus z plus d equal to 0. That's all. Okay, answer is x minus 2y plus z is equal to z plus 1 is equal to 0. Now one more question. Find the equation of a plane passing through 1 minus 1, 2. Find the equation of a plane passing through 1 minus 1, 2. 1 minus 1, 2. Find the equation of plane passing through 1 minus 1, 2. And is perpendicular to a vector. And is perpendicular to a vector I plus 2j minus 3k. I plus 2j minus 3k. Here x1 y1 z1 is already given 1 minus 1, 2. x1 y1 z1 is equal to 1 minus 1, 2 and ABC normal vector direction ratios are 1, 2, minus 3 and therefore the equation of the plane is uniform x minus x1 into a plus y minus y1 into b plus z minus z into c is equal to 0. It is x minus 1 into 1 plus y minus or minus 1 y plus 1 into b 2 z minus 2 into minus 3 is equal to 0. That is x minus 1 plus 2y plus 2 minus 3z plus 6 equal to 0. And therefore x plus 2y minus 3z minus 1 plus 2 is 1. 1 plus 6 is 7 equal to 0, which is a Cartesian equation. If you want to find a vector form, then we substitute a and n to the given equation. That's all. Okay, that is r minus a correspond to I minus j plus 2k dot n correspond to I plus 2j minus 3k. Dot product we get answer. That's all. It's very simple. Okay, now we'll discuss our next topic is also very important. Equation of a plane passing through three fixed points. Equation of a plane passing through three fixed points. Equation of a plane passing through three fixed points. Equation of a plane passing through three fixed points. Here we had only the Cartesian form. Write only two form. I mean vector form and Cartesian form not here, but we concept only in by heart only in Cartesian form. Okay, our vector form is equation of a plane passing through vector form. Proof നമുക്ക് ആവശ്യമില്ല, അതുകൊണ്ടാണ് ഞാൻ ഒഴിവാക്കുന്നത്. Vector form is vector r minus vector a dot b minus vector a cross c minus vector a equal to 0, which is the vector equation of a plane passing through three fixed points. Here vector a, vector b and vector c represent position vectors of three fixed points. That means a plane passing through three fixed points. Okay, a plane pass through three fixed points A, B and C. Then how to form the equation of that plane? Okay, using if you want to find the vector form, use this formula r minus a dot b minus a cross c minus a. And this Cartesian form is very important. Cartesian form is determinant. It's very simple, but it's very important. X minus x1, y minus y1, z minus z1. Second row, x2 minus x1, y2 minus y1, z2 minus z1. Third row, x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. This is the Cartesian form. Okay, equation of a plane passing through three fixed points. First point coordinate is x1, y1, z1. Second coordinate is x2, y2, z2, and third point coordinate is x3, y3, z3. Then the equation of the plane is determinant x minus x1, y minus y1, z minus z1. Second row, x2 minus x1, y2 minus y1, z2 minus z1. Third row, x3 minus x1, y3 minus y1, z3 minus z1. First point coordinate is x1, y1, z1. Second point passing in the second point coordinate is x2, y2, z2, and third point coordinate is x3, y3, z3. Then the equation of the plane is determinant x minus x1, y minus y1, z minus z1. Second row, x2 minus x1, y2 minus y1, z2 minus z1. Third row, x3 minus x1, y3 minus y1, z3 minus z1. Okay, now we will discuss some direct problems based on the topic. Find the equation of a plane passing through the points 1, 1, 0. x1, y1, z1 is equal to 1, 1, 0. Second is x2, y2, z2. 1, 2, 1, 1, 2, 1. x3, y3, z3. minus 2, 2, minus 1. Find the equation of the plane. We want to find only equation, I mean Cartesian equation of the plane passing through the points 1, 1, 0, 1, 2, 1 and minus 2, 2, minus 1. Question is find the equation of the plane that pass through the point is 1, 1, 0, 1, 2, 1 and minus 2, 2, minus 1. Okay, first of all you write the equation of the plane. Equation of the plane. You already know Cartesian equation of the plane is x minus x1, y minus y1, z minus z1. Second row, x2 minus x1, y2 minus y1, z2 minus z1. Third row, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. And therefore determinant here x minus 1, y minus 1, z minus 0 then x2 minus x1, that is 1 minus 1 is 0, y2 minus y1, 2 minus 1 is 1, z2 minus z1, 1 minus 0 is again 1, x3 minus x1, minus 2 minus 1 is minus 3, 2 minus 1 is 1, minus 1 minus 0 is again minus 1 is equal to 0. Now expand the determined value, we get answer x minus 1 into minus 1 is minus 2, minus of y minus 1 into 0 minus 1 minus 3 plus 3 plus z minus 0 into 0 minus 1 minus 3 plus 3 equal to 0. Now multiply, we get answer minus 2x plus 2, then minus 3y, minus into minus plus 1 into 3 plus 3, 3z equal to 0, and therefore minus 2x minus 3y plus 3z, 3 plus 2 plus 5 equal to 0. That's the equation of the plane passing through 3 fixed point. It's a very important section. 2x minus 3y plus 3z plus 5 equal to 0. It's a Cartesian form. Okay. Now if we want to form the vector form, we directly substitute here and we find a cross product also. Otherwise, a second method is available. If you want to find the vector form, then you directly write if Cartesian form കണ്ടെത്തിയതിനു ശേഷം vector form നമുക്ക് എങ്ങനെ വേണമെങ്കിൽ എഴുതാം, r dot minus 2y minus 3j plus 3k plus 5 equal to 0 നമുക്ക് റെപ്രസെൻറ്റ് ചെയ്യാം. വെക്ടർ കാർട്ടീഷ്യൻ ഫോം റെപ്രസെൻറ്റ് ചെയ്തതിനു ശേഷം ലാസ്റ്റ് XY പകരം IG ഒക്കെ കൊടുത്ത് വെക്ടർ r ഡോട്ട് minus 2i minus 3j plus 3k plus 5 എന്നും റെപ്രസെൻറ്റ് ചെയ്യാം. അതർവൈസ് ഡയറക്റ്റ് ഫോമിൽ ബൈ ഹാർട്ട് ആക്കി ഉണ്ടെങ്കിൽ അതിൽ കൊടുത്ത് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തും ചെയ്യാം. ഓക്കെ. Okay, one more question നമുക്ക് ഡിസ്കസ് ചെയ്യാം. ഇതിനെ ബേസ് ചെയ്ത് ഇക്വേഷൻ ഓഫ് എ പ്ലെയിൻ ആൻഡ് ദ ഇക്വേഷൻ ഓഫ് എ പ്ലെയിൻ പാസിംഗ് ത്രൂ ദ പോയിന്റ്സ് ആർ 1 1 minus 1. Equation of a plane pass through the points 1 1 minus 1 2 3 5 and minus 1 4 minus 5. Equation of a plane pass through the points, that mean x1 y1 z1 equal to 1 1 minus 1, x2 y2 z2 is equal to 2 3 5 and x3 y3 z3 is equal to minus 1 4 minus 5. Equation of plane passing through the points 1 1 minus 1 2 3 5 and minus 1 4 minus 5. You know the equation of the plane. You know the equation of the plane is determinant x minus x1 y minus y1 z minus z1 x2 minus x1 y2 minus y1 z2 minus z1. Third row x3 minus x1 y3 minus y1 z3 minus z1 is equal to 0, and determinant, that is x minus 1 y minus 1 z minus or minus z plus 1. 2 minus 1 is 1, 3 minus 1 is 2, 5 minus or minus 1 6, minus 1 minus 1 minus 2, 4 minus 1 3, minus 5 plus 1 minus 4 equal to 0. Then you find the determinant value, that is x minus 1 into minus 8 minus 18, that is minus 26, minus y minus 1 into, you get 8, plus z plus 1 into, you get 7 equal to 0. Now multiply this term, we get answer minus 26x minus 8y plus 7z, constant adding by 26 plus 8 plus 7, we get answer 41. That's the equation. If we want to find the vectoric form, at that time equation of the plane is, and last we write equation of the plane is r dot minus 26i minus 8j plus 7k plus 41 is equal to 0, which is the vector form, which is the Cartesian form. This is the vector form. Okay. Now discuss our next section is interceptive form of the equation of the plane. Interceptive form is also direct equation. And this is direct equations. Interceptive form. intercept form. Okay, that means a plane which intercept on three axes of a space. That means x, y and z. ഈ മൂന്ന് ആക്സിലും ഇൻ്റർസെക്റ്റ് ചെയ്തുകൊണ്ട് ഒരു പ്ലെയിൻ ഇങ്ങനെ കടന്നു പോയി കഴിഞ്ഞാൽ, okay, then how to form the equation of that plane? Proof നിങ്ങൾക്ക് ഇമ്പോർട്ടൻ്റ് അല്ല. ജസ്റ്റ് ഇപ്പോൾ സപ്പോസ് എക്സ് ഇൻ്റർസെപ്റ്റ് ഈസ്, സപ്പോസ് വി കൺസിഡർ എക്സ് കോർഡിനേറ്റ്, ഒറിജിൻ ടു എക്സ് കോർഡിനേറ്റ് ഈസ് കൺസിഡർ എ, വൈ ആൻഡ് സെഡ് ആർ 0. Second is b, 0, b, 0. And third is 0, 0, c. Okay, then what is the equation of that plane? Now here equation of the plane is, directly നമുക്ക് എഴുതാം, a equation of a plane passing through three fixed point a0, 0, a 0, 0, 0, a small a 0, 0, 0, b 0, b 0 and c 0, 0, c. Then equation of the plane, ഇവിടെ നിങ്ങൾക്ക് ഒരൊറ്റ ഫോം മാത്രം പഠിച്ചിരുന്നാൽ മതി, കാർട്ടീഷ്യൻ ഫോം, x by a plus y by b plus z by c equal to 1, which is the intercept form of the equation of the plane, x by a plus y by b plus z by c equal to 1. ഈ പ്ലെയിനിൻ്റെ ഇക്വേഷൻ 3 പോയിൻറ്റ് പാസ് ചെയ്യുന്ന പ്ലെയിനിൻ്റെ ഇക്വേഷനിൽ ഈ a0, 0, 0, b 0, x1 y1 സെറ്റിന് വരാം, a0, 0, s2 y2 സെറ്റിന് വരാം, 0, b 0 ആൻഡ് x3 y3 z3ക്ക് വരാം, 0, 0, c സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ വി ഗെറ്റ് ഡിറ്റർമിൻഡ് എക്സ്പാൻഡ് ചെയ്യുമ്പോൾ വി ഗെറ്റ് ആൻസർ. പ്രൂഫ് ആവശ്യമില്ലാത്തതുകൊണ്ട് ഞാൻ എഴുതി. Equation is x by a plus y by b plus z by c is equal to 1. That's all. It's an equation. Okay. Now we will discuss some problem using this formula. Find the equation of the plane. Find the equation of the plane with the intercept 2, 3, 4 on x, y, z axis respectively. Find the equation of the plane which intercept 2, 3, 4 on x, y, z axis respectively. That means it's intercept, that means x intercept, y intercept and z intercept are already given. That is given a is equal to 2, b is equal to 3 and c is equal to 4. This 2D form is already learned in our first year class in straight line. Okay, it's a 3-dimensional form. X intercept, x intercept ചെയ്യുന്ന ദൂരം a2, y intercept ചെയ്യുന്ന ദൂരം b3 and z intercept ചെയ്യുന്ന ദൂരം c. That is a equal to, b equal to 3 and c equal to 4 is already given. Now the equation of the plane is, x by a plus y by b plus z by c is equal to 1. That is x by 2 plus y by 3 plus z by 4 is equal to 1. Then you arrange LCM, you know, 2, 3, 4 LCM is 12. 12 form, multiply numerator and denominator by 6, that is 6x by 12. Now multiply numerator by denominator 4, that is 4y by 12 and 3z by 12, equal to 1. That implies 6x plus 4y plus 3z equal to answer 12, which is the equation of a plane. 6x plus 4y plus 3z is equal to 12. Okay, it's a very simple question. Now discuss one more question. Find the equation of the plane which intercept on x, y, z axis at 1, 1, 2. That is a is equal to 1, b is equal to 1 and c is equal to 2. You know the equation. Equation of the plane is x by a plus y by b plus z by c is equal to 1. That is x by 1 plus y by 1 plus z by 2 is equal to 1. Here LCM is 2. It is 2x plus 2y plus z is equal to 2, which is the equation. If you want to find the vector form, then the vector form is vector form. Okay, Cartesian form in the vector form represent here. I mean r dot 2i plus 2j plus k is equal to, which is the vector form. That's all. Okay. Now discuss one more question. Find the intercept cut off by the plane. Find intercept cut off by the plane. Find the intercept cut off by the plane. Find the intercept cut off by the plane 2x plus y minus z equal to 5. Find the intercept cut off by the plane 2x plus y minus z equal to 5. That means here given plane is 2x plus y minus z equal to 5. Intercept for, we find the ABC. First of all, dividing throughout by 5 because we right side equation right side 1 ABC form convert cheyyam. So dividing throughout by 5 we get answer 2x divided by 5 plus y by 5 minus z by 5 is equal to 1. It is x divided by 5 by 2 plus y by 5 plus z divided by minus 5 equal to 1, and therefore the intercept cut off by the plane are A is equal to 5 by 2, B is equal to 5 and C is equal to minus 5. That's all. It's a very simple question, but it is a very important question. Okay, that's all today's class. Our next class we will discuss our next topic is direct questions are already learned.